Suppose we want to solve the equation 5 to the power of x equals 4. Well, we know that 5 to the power of 0 equals 1. Any number to the power of 0 is 1. We also know that 5 to the power of 1 equals 5. So we expect our answer to lie between 0 and 1. So we expect our answer to be 0 point something or other. Now the way we solve an equation like this is we get the log of both sides. So I'll highlight that here. So we get the log of 5 to the power of x, and it must equal the log of 4. Then we use one of the rules that was covered in the previous video. If we have the log of something raised to a power, then we can multiply in front by that power. So this becomes x log of 5 equals log of 4. And it doesn't matter what the base is for these logs. You can use any base you like, but of course you pick a base that's on your calculator, and that base is base 10. There's also another button on your calculator called ln, which actually stands for log to the base e. So if you're getting ln of x, you're getting log to the base e of x. E is about 2.7. It's an irrational number, but I won't discuss this in this video. I'll discuss that in the videos on calculus. But we could of course use it here. So ln just means log to the base e. I'll use this one. Actually, I'll use both of them. So then it's an easy matter to solve for x. We just divide across by log to the base 10 of 5. So we get the log to the base 10 of 4 and divide by log to the base 10 of 5. So to 3 decimal places we get 0.861. If you want to use the ln button, we have x equals ln of 4 divided by ln of 5. Get the same thing. Of course, the ln, or log to the base e of 4, is very different from log to the base 10 of 4. Same for ln of 5 and log to the base 10 of 5. It's just that the ratio works out to be the same. Now if we want to check this, we could put 5 to the power of x, and we should get 4, or close to 4, because remember we rounded this to 3 decimal places. So we get 3.997. That's close enough. It's approximately 4. Solve log to the base 2 of x plus 6 minus log to the base 2 of x plus 2 equals 1. Now in this equation we have two log terms, and the two terms have the same base. So what we try to do is combine them into a single log term. So we use the following result, which I proved in the last video. Log to the base a of m minus log to the base a of n equals log to the base a of m divided by n. So bases have to be the same. A can be any number, but they have to be the same, and they are here. A is 2 in this case. M is the argument of this log function. N is the argument of this other one. So we put the first argument over the second argument. We put m over n. M appears on top over n. So we want to write this as a single term. So it's log to the base 2 of this first argument, which is x plus 6, divided by the second argument, which is x plus 2, and that must equal what we have on the right hand side, which is 1. Now all we do now is apply the definition of the log function. We have a single log term and a number on the right hand side, so that means that 2 to the power of 1 must equal the argument. So the argument is 2 to the power of 1, which is 2. So now we can solve this equation by multiplying both sides by x plus 2. It's just a linear equation. So we get x plus 6 equals 2x plus 4, which means that x equals 2. Now that is a general strategy. If you have several log terms, try to combine them into a single log term. So if they're subtracted, we use this rule here. If they're added, we have a different rule. Let's just check this value that we got. So we plug it in here. So we get log to the base 2 of x, which is 2. 2 plus 6 is 8. Minus log to the base 2 of 2 plus 2, which is 4. So I just plugged 2 in for x. And hopefully this will work out to 1. Let's see that. Well, log to the base 2 of 8 we can work out without having to use a calculator, because 2 to the power of 3 is 8. Log to the base 2 of 4 is 2, because 2 to the power of 2 is 4, and 3 minus 2 is 1, which is indeed the right hand side. So it does check out. Solve the equation log to the base e of 2x plus 3 plus log to the base e of x minus 2 equals 2 log to the base e of x plus 4. Now I explained earlier that the number e is about 2.718, etc. It's a very important number in calculus, but I won't discuss it too much here. Log to the base e of a number appears as ln on your calculator. So if we're getting log to the base e of 3, you press the ln button on your calculator and then 3. Now, all the log terms have the same base, so we don't have to be changing bases. They're all base e. We can combine these two terms together using a rule that was proven in the previous video, which said that log to the base a of m plus log to the base a of n equals log to the base a of m times n. So we multiply the arguments when we're adding these log terms. So this becomes log to the base e of 2x plus 3 multiplied by x minus 2. So m is 2x plus 3, n is x minus 2, and we multiply the arguments. Now we can apply another rule that you saw in the previous video, and if we want to get rid of this 2, then it's much easier to compare both sides if we can write the right hand side like this. So just to remind you, if we have log to the base a of m to the power of n, then we can multiply n in front. So we get n log to the base a of m. So this is the rule that I'm using here. So n is actually 2, and we can bring it up here if you like. So we get m to the power of n, or x plus 4 to the power of 2. Now why do we do that? Well, if we can cancel the log terms effectively on both sides. We couldn't do that if we have a 2 in front on the right hand side. See, we're just taking the same operation on both sides. We're getting the log of both sides. We're not multiplying, and then we're not following it up with multiplication by some number. We don't have that now because that 2 has been brought up. So we can just get the inverse of that operation. Effectively what we're doing is getting e to the power of both sides. E to the power of log to the base e of this argument equals e to the power of log to the base e of this argument here. And we're just undoing the operation of taking the log by raising all of this, raising e to the power of all of this. A simpler example to see what's going on here, if you like, is if we take, say, log to the base 10 of 100. What power do we raise 10 to get 100? And the answer is 2. So if we raise 10 to the power of log to the base 10 of 100, well, we just get 100. So these just cancel each other out in a sense, and we get this. 10 to the power of 2 is 100. So e to the power of log to the base e just effectively we have cancelling here. So we can just cross off these. You don't have to show this line. So we got a quadratic equation. We just equate the arguments. So it looks like we have to solve a quadratic equation, so we'll have to get it into standard form. We have 2x by x is 2x squared. We have minus 4x plus 3x, that's minus 1x. Then we have minus 6. Over here we have x squared plus 8x plus 16. So we get it into standard form. That means we want 0 on one side. We get x squared minus 9x minus 22 equals 0. We get the factors of this quadratic. We put each factor equal to 0. So we get x equals 11 or x equals minus 2. Let's do a check. Let's start with x equals 11. So what have we got? We've got log to the base e, which I can write as ln of 2 times 11 plus 3. 2 times 11 is 22. 22 plus 3 is 25. Plus ln, which means log to the base e, of 11 minus 2, which is 9. So that's the left-hand side. On the right-hand side, we have 2 times ln of 11 plus 4, or 2 times ln of 15. Now let's work out the left-hand side. So we have 25 ln, that means log to the base e of 25, plus ln of 9. So that's 5.42. Let's get 2 times ln of 15. So we also get 5.42. So x equals 11 is indeed a solution of this equation. Now there's a problem with this solution here. X equals minus 2 is indeed a solution of this quadratic equation. But the problem is when we plug minus 2 into here, we get a negative argument. See, this is log to the base e, or ln, of minus 2 minus 2, which is minus 4. Ln of minus 4. And that doesn't exist. You know, ln of minus, or log to the base e of minus 4. E is a positive number. It's 2.718 to 3 decimal places. No matter what number we raise e to, we always get a positive number. E to the power of any number is positive, because e is positive. So if you try to work this out, you get an error. So this thing, no real number. There is no real number for ln of minus 4. So we disregard this value of x and conclude that there is one solution, x equals 11. As a matter of fact, if we put minus 2 in here, we don't have, well, actually we do have a problem, because 2 times minus 2 is minus 4 plus 3. That comes out negative. So, you know, for some arguments it mightn't come out negative, but it actually does for this one and this one, and even, well, no, it doesn't for this one actually. If we plug minus 2 in here, we get the log of plus 2, but it doesn't matter. We can't calculate this thing, so we have to disregard this solution.